All right, today we're diving into something really cool. We're going to look at how AI basically acts like a detective, how it solves mysteries in this massive world of messy, unlabeled data. This whole idea is the heart of unsupervised learning, and we are about to crack the case. Okay, so imagine this. Someone hands you a jigsaw puzzle, a huge one with like a million pieces. But here's the twist. There's no picture on the box, no guide, no final image, nothing. You just have a mountain of pieces. I mean, where would you even begin? Well, that puzzle, that's exactly the challenge AI faces every single day. You see, most of the world's data, everything from what's in our shopping carts to our social media feeds, it doesn't come with a neat little picture on the box. It's just this giant sea of raw, chaotic information. So, to solve a puzzle that massive, you're going to need a special kind of hero, right? So let's meet our protagonist, unsupervised learning, the AI data detective. This is the method AI uses to find all the hidden clues and crack the case completely on its own. So what's its secret? What makes this detective so special? Well, unlike other AI methods, it's given this huge pile of evidence with zero instructions. Nobody tells it, hey, this is a fingerprint or that's a footprint over there. It has to sift through everything and figure out the hidden patterns and groupings all by itself. The detective's process is actually pretty methodical. It starts with all that raw, unlabeled data, the messy crime scene. From there, it starts to identify hidden structures, things that look similar. Then comes the really crucial part, step 3. It learns a whole new way to represent that data, to simplify the chaos. And finally, it presents its findings, these incredible insights and patterns that were hiding in plain sight the whole time. Of course, every great detective has a specialized toolkit, right? And our AI detective is no different. It's got 3 main tools it pulls out to crack different kinds of cases. So let's open up that toolkit and see what we're working with. First up is clustering. This is like the detective's bread and butter, the most essential tool in the kit. Just think of it like sorting evidence at a crime scene. You put all the fingerprints in one pile, all the shoe prints in another, all the fabric fibers in a third. At its core, it is simply about grouping similar things together. And we see this tool's power absolutely everywhere. Businesses use clustering for what they call customer segmentation, grouping buyers together who have similar habits. A super popular algorithm for this is K-means. It's the key to making sense of these massive populations of data, from sorting social networks to powering scientific research. All right, the second tool in the kit is dimensionality reduction. Now, that sounds complicated, but the idea is actually pretty simple. Imagine a case with thousands of pieces of evidence, and most of it is just junk, totally irrelevant. It would be overwhelming. Well, this tool acts like a filter, helping the detective ignore all that noise and focus only on the critical clues that are actually going to solve the case. And you know what? We use this every single day without even realizing it. Is how our photos get compressed into smaller files without losing a ton of quality. And a technique like t-SNE, it's amazing. It can take data with hundreds of different features and just plot it on a 2D map, creating these stunning visuals that help us see patterns in what would otherwise just be a wall of numbers. And the final tool we're going to look at is called association rule mining. This one is all about finding those hidden relationships. It's like a detective noticing that, hey, this suspect always buys a coffee and a newspaper right before doing something suspicious. It finds those if this, then that patterns that show us how different things are connected. The most famous example here, the one everyone talks about, is market basket analysis. This is the secret sauce behind all those store recommendations you see. Algorithms like a priori just scan through millions of shopping carts to find those hidden if-then rules, discovering connections that literally drive how products get placed on shelves and what gets recommended to you online. Okay, so we've met the detective, we've looked inside the toolkit, but how does all this actually affect our lives? Let's look at a few real-world mysteries that this AI detective has already solved for us. I mean, have you ever been shopping and it just feels like the store gets you? It seems to know exactly what you're looking for, maybe even before you do. How on earth do they pull that off? Yep, that's our friend association rule mining. The system has analyzed millions of shopping carts and learned a really simple rule. People who buy bread and butter are also very, very likely to buy jam. So what does the store do? It puts the jam on sale right next to the butter. It's a simple insight, but it's incredibly effective. Or think about this one. You get a text from your bank about a suspicious charge on your card, like seconds after it happens.
how can they be that fast? Is there someone sitting there just watching every single transaction in real time?
The answer is clustering, but it's being used for something really clever called anomaly detection. The system has already grouped all of your normal spending habits into this tight little cluster. So when a new transaction comes in that falls way outside of that cluster, like a sudden $1,000 purchase in another country, bam! It's immediately flagged as an outlier, and that triggers the fraud alert.
And finally, the one we have all experienced. You're browsing online and an ad pops up for something so specific, so perfectly tailored to you that it feels a little uncanny. How is that even possible?
Once again, it's clustering doing the heavy lifting. This time, it's being used for customer segmentation. The algorithm looks at your browsing habits, your purchases, your interests, and then it groups you with millions of other people who act in a similar way. And that group, that becomes a very specific target audience for advertisers. Now, at this point, it might seem like our AI detective is flawless, like some kind of superhero who always gets it right. But that's not quite the whole story. Like any good detective, it has its blind spots and its challenges. It's incredibly powerful, but it's not perfect.
You know, the biggest challenge is just validation. Without that picture on the box, how do you even know if the solution is correct? There's no right answer key. Sometimes the patterns it finds are totally meaningless in the real world. And the whole process is super sensitive to messy data, and even choosing how many groups to sort things into can feel more like an art than a science.
But here's the key takeaway. Yeah, there are challenges, for sure. But the power of this approach is just immense when it's used correctly. It's a tool for pure exploration, for finding the insights you didn't even know you were looking for. It's about automating discovery on a massive, massive scale. And that leaves us with this final, really powerful question. This AI detective is already uncovering patterns in our world that were completely invisible to the human eye. So, what other fundamental structures in biology, in finance, maybe even in the universe itself, are just out there, waiting to be discovered by an algorithm that has no picture on the box?